All right, let's see now. Why is u substitution referred to as a change of variable? Oh man, I'm not even gonna write this down because you are changing the variable from x to u. Bleh. Right, if f equals g composed with h, when reversing the chain rule, should you take u as g or u as h? So usually I think you want to go with the h. You kind of want to go with what's like inner, the inside part. So that would be the h. So like for example here, I would choose the u to be this part here in 256. So let's test it out. If u equals x plus 1, then what's nice about this is du dx equals 1, which means du equals dx. So this would become the integration of x, which would be u minus 1, times root x plus 1, which is u. And dx would become actually du. So we could simplify this even more because you could multiply in this. So u1 times u power a half is u3 over 2 minus u a half du. And there you go. You'd integrate it and you could sub the u back in. So um, we would get, if we were to continue, but I'm not sure if they want us to continue. Oh, they just want us to identify the f. So the f of u, I would write it as u power 3 over 2 minus u power a half. And that would allow, that's in a very easy to integrate form. And so we could solve this integration. But they also want us to check that this does differentiate to this. So let's differentiate. So this is the product rule. So bring down the power, reduce the power by 1, keep the second bracket the same, keep the first bracket the same, and differentiate the second bracket, and c becomes 0. Oh, actually, they even tell us what substitution to use. Okay, so clean up time. It's going to be a bit messy to clean up, isn't it? 3 goes into 3 once, 3 goes into 15 5 times, the 2's cancel. That would be 2/5 root x plus 1 times 3x minus 2 plus 2/15 root x plus 1 cubed times 3. So that's, oh, actually, so I can do the same thing. 3 goes into 3 once, 3 goes into 5, 15 5 times. So that's 2 over 15. Now, maybe I should split this as x plus 1 times root x plus 1, because that's, if I bring that in, it would make the cubed. And then that means I can take out the 2 over 5, I can take out the root x plus 1, and I'm left with 3x minus 2 plus x plus 1. So that would be 2/5 root x plus 1 times 4x minus 1. No, I made a mistake somewhere in my differentiating. Bring down the power, reduce the power by 1, multiply by 1, keep that the same, plus 2/15 x plus 1 power 2. And then the derivative there is 3. Have I made a mistake? Let us check. X square root x plus 1. Integrate. Yeah. So, or actually, that doesn't seem to match up because this answer, when you integrate x times root plus x, integrate x root x plus 1, it has an x squared as a coefficient in the answer. What I'll do also is I'll type this in and differentiate it. Two over 15 x plus 1 power 2 over 3x minus 2. Differentiate. Ah, it does differentiate. So that means I have made a mistake. Or, there's more simplifying I can do. All right, let's go back in time and try this again and just be a little bit more careful. Okay, so product rule. Let's differentiate this. So that's 2 over 15. Bring down the power, reduce the power by 1, and then multiply by the inside derivative, which is 1, and keep the second bracket the same. And then keep the first bracket the same, 2 over 15, x plus 1 power 3 over 2, and then differentiate the second bracket, and then the c becomes 0. Okay. That's a 15. Why did I write 5? I said be careful, Stephen. All right. 2's cancel. 3 goes into 3 once. 3 goes into 15 5 times. So I'm left with just 5 here. 3 goes into 15 5 times. Okay, so I have a 1 over 5 here. And I have a 2 over 5 here. Okay. Now, so I can also, this is power 3 over 2 is power 1.5. So what I can do is I can split this into x plus 1 and x plus 1 a half. So now if I highlight here, I've got x plus 1 power a half and x plus 1 power a half and the 5 that I can take out. So let's take that one out. Root x plus 1 over 5 times 3x minus 2. And then here, there's a 2 here, so I should multiply in the 2. So that's 2x plus 2. So that's a 1 over 5, so that can come out with the root. Plus 2x plus 2. Ah, maybe that was it. The multiplying by 2 I might have missed. Because now these cancel. And that's root x plus 1 over 5 times 5x. And the 5's cancel. And that's left with x root x plus 1. So, good. We've confirmed that the derivative works. And we've written this in the form that they want. So I think we're okay now with this question. Yeah. I'll just check here something. So if I have u power 3 over 2 minus u power a half, and I integrate that, and then I sub in x plus 1 for u. And then that should be identical to 1 with only the difference of the c. So if I sub in c is just 0 for the moment. And is 7 the same as 8? Let's see. Yes, it is. So we are good now. Okay, I feel like this exercise is going to take a while to do because you're going to have to get the integral, and then you're going to have to differentiate here the antiderivative to confirm that it's correct. Well, at least there's only 5 of them. The rest, I think, would be more straightforward to do, actually. So it's going to be a rough start to this exercise. All right.